using Python's assert to debug and test your code. Python's assert statement allows you to write sanity checks in your code. These checks are known as assertions, and you can use them to test if certain assumptions remain true while you're developing your code. If any of your assertions become false, then you have a bug in your code. Assertions are a convenient tool for documenting, debugging, and testing code during development. Once you've debugged and tested your code with the help of assertions, then you can turn them off to optimize the code for production. Assertions will help you make your code more efficient, robust, and reliable. In this course, you'll learn what assertions are and when to use them, how Python's assert statement works, how assert can help you document, debug, and test your code, how assertions can be disabled to improve performance in production, and what common pitfalls you might face when using assert statements. To get the most out of this course, you should have previous knowledge of expressions and operators, functions, conditional statements, and exceptions. Having a basic understanding of documenting, debugging, and testing Python code is also a plus. As ever, Real Python has you covered with this course on expressions and operators, this one on functions, this one on conditional statements, and this one on exceptions. You can check out this one for documentation, this one for debugging, and this one for testing. Any code that you see running in the REPL will be using the BPython interpreter. This is a replacement Python interpreter that offers a number of enhancements, including code highlighting and suggestions, but any code you see running on screen will work in the Python REPL, which is typically accessed by typing Python or Python 3 at your terminal or command line prompt. So now you know what's going to be covered, let's get started. Getting to know assertions in Python. Python implements a feature called assertions that are pretty useful during the development of your applications and projects. You'll find this feature in several other languages too, such as C and Java, and it comes in handy for documenting, debugging, and testing your code. If you're looking for a tool to strengthen your debugging and testing process, then assertions are for you. In this part of the course, you'll learn the basics of assertions, including what they are, what they're good for, and when you shouldn't use them in your code. In Python, assertions are statements that you can use to set sanity checks during the development process. Assertions allow you to test the correctness of your code by checking if some specific conditions remain true, which can come in handy while you're debugging code. The assertion condition should always be true unless you have a bug in your program. If the condition turns out to be false, then the assertion raises an exception and terminates the execution of the program. With assertions, you can set checks to make sure that invariants in your code stay invariant. By doing so, you can check assumptions such as preconditions and postconditions. For example, you can set test conditions along the lines of this argument is not none or this return value is a string. These kind of checks can help you catch errors as soon as possible when you're developing a program. Assertions are mainly for debugging. They'll help you ensure that you don't introduce new bugs while adding features and fixing other bugs in your code. However, they can have other interesting use cases within your development process. These use cases include documenting and testing your code. The primary role of assertions is to trigger the alarms when a bug appears in a program. In this context, assertions mean make sure that this condition remains true, otherwise throw an error. In practice, you can use assertions to check preconditions and postconditions in your programs at development time. For example, programmers often place assertions at the beginning of functions to check if the input is valid, preconditions, and also before return values to check if the output is valid, postconditions. Assertions make it clear that you want to check if a given condition is and remains true. In Python, they can also include an optional message to unambiguously describe the error or problem at hand. That's why they're also an efficient tool for documenting code. In this context, their main advantage is their ability to take concrete action instead of being passive, as comments and docstrings are. Finally, assertions are also ideal for writing test cases in your code. You can write concise and to-the-point test cases because assertions provide a quick way to check if a given condition is met or not, which defines whether the test passes or fails. You'll learn more about these common use cases of assertions later on in the course. But what about when you shouldn't use assertions? In general, you shouldn't use assertions for data processing or data validation because you can disable assertions in production code, which ends up removing all of your assertion-based processing and validation. Using assertions in this way is a common pitfall, and you'll learn more about this later on in the course. Additionally, assertions aren't an error handling tool. The ultimate purpose of assertions isn't to handle errors in production, but to notify you during development so you can fix them. In this regard, you shouldn't write code that catches assertion errors using a regular try-except statement. In the next section of the course, you'll get started by using assert statements. Understanding Python's assert statements. You now know what assertions are, what they're good for, and when you shouldn't use them in your code. It's time to learn the basics of writing your own assertions. First, note that Python implements assertions as a statement with the assert keyword rather than as a function. This behavior can be a common source of confusion and issues, as you'll learn later on. An assert statement consists of the assert keyword, the expression or condition to test, and an optional message. The condition is always supposed to be true. If the assertion condition is true, then nothing happens, and the program continues its normal execution. On the other hand, if the condition becomes false, then assert halts the program by raising an assertion error. In Python, assert is a simple statement with the syntax seen on screen. Here, expression can be any valid Python expression or object, which is then tested for truthiness. If expression is false, then the statement throws an assertion error. The assertion message parameter is optional but encouraged. It can hold a string describing the issue that the statement is supposed to catch. Here's how the statement works in practice. With the truthy expression, the assertion succeeds and nothing happens. In that case, the program continues its normal execution. In contrast, a falsy expression makes the assertion fail, raising an assertion error and breaking the program's execution. To make your assert statements clear to other developers, you should add a descriptive assertion message. The message in this assertion clearly states which condition should be true and what is making the condition fail. Note that the assertion message argument to assert is optional. However, it can help you better understand the condition under test and figure out the problem that you're facing. So whenever you use assert, it's a good idea to use a descriptive assertion message for the traceback of the assertion error exception. An important point regarding the assert syntax is the statement does not require a pair of parentheses to group the expression and the optional message. In Python, assert is a statement, not a function. Using a pair of parentheses can lead to unexpected behaviors. For example, an assertion such as the one seen on screen will raise a syntax warning. This warning has to do with non-empty tuples always being truthy in Python. In this example, the parentheses turn the assertion expression and message into a two-item tuple, which always evaluates to true. Fortunately, recent versions of Python throw a syntax warning to alert you of this. However, in older versions of the language, an assert statement, as seen on screen, will always succeed. This issue often appears when you're using long expressions or messages that take more than a single line. In these cases, the parentheses are the natural way to format the code, and you may end up with something like the code seen on screen. Using a pair of parentheses to split a long line into multiple lines is a common formatting practice in Python code. However, in the context of an assert statement, the parentheses turn the assertion expression and the message into a two-item tuple. In practice, If you want to split a long assertion into several lines, then you can use the / character for explicit line joining. The / at the end of the first line of this assertion joins the two physical lines into a single logical line. This way, you can have an appropriate line length without the risk of a warning or a logical error in your code. PEP 679 was created in January 2022 and is proposing to allow parentheses around the assertion expression and message. If the PEP gets approved and implemented, then the issue of accidental tuples won't affect Python code in the future. There is an edge case of this parentheses-related issue. If you provide only the assertion expression in parentheses, then assert will work just fine. Why is this happening? To create a single item tuple, you need to place a comma after the item itself. In the code on screen, the parentheses by themselves don't create a tuple, and that's why the interpreter ignores the parentheses and assert works as expected. Even though the parentheses work in this scenario, it's not a recommended practice. You can end up shooting yourself in the foot. If the condition of an assert statement evaluates to false, then assert raises an assertion error. If you provide the optional assertion message, then this message is internally used as an argument to the assertion error class. Either way, the raised exception breaks your program's execution. Most of the time, you won't raise assertion error exceptions explicitly in your code. The assert statement takes care of raising this exception when the assertion condition fails. Additionally, as you'll learn later on, you shouldn't attempt to handle errors by writing code that catches the assertion error. Finally, assertion error is a built-in exception that inherits from the exception class and is considered a concrete exception that should be raised instead of subclassed. Now you know the basics of the assert statement. You've learned the statement syntax, how it works in practice, and also what the main characteristics of the assertion error exception are. It's time to move forward and explore some effective and common ways to write assertions in Python, and that's what you'll be looking at in the next section of the course. Exploring common assertion formats. When it comes to writing the assert statement, you'll find several assertion formats that are common in Python code. Being aware of these formats will allow you to write better assertions. The examples that you'll see showcase a few of these common formats, starting with assertions that compare objects. Comparison assertions are intended to test conditions that compare two or more objects using comparison operators. These assertions can also include compound expressions based on Boolean operators. Another common assertion format is related to membership tests. Membership assertions allow you to check if a given item is present in a specific collection, such as a list, tuple, set, or dictionary. These assertions use the membership operators in and not in to perform the required check. Another assertion format is related to an object's identity. Identity assertions provide a way to test for an object's identity. In this case, the assertion expression uses the identity operators is and is not. Finally, you'll see how to check the data type of objects in the context of an assertion. Type check assertions commonly involve using the built-in isInstance function to make sure that a given object is an instance of a certain class or classes. Even though these are some of the most common assertion formats that you'll find in Python code, there are many other possibilities. For example, you can use the built-in all and any functions to write assertions that check for the truth value of items in an iterable. The all assertions check if all the items in an input iterable are truthy, while the any examples check if any item in the input iterable is truthy. Your imagination is the only limit for writing useful assertions. You can write assertions using predicate or Boolean valued functions, regular Python objects, comparison expressions, Boolean expressions, or general Python expressions. Your assertion will depend on what specific condition you need to check at any given moment. Now you know some of the most common assertion formats you can use in your code. It's time to learn about specific use cases of assertions, and in the next section of the course, you'll learn how to use assertions to document your code. Documenting your code with assertions. The assert statement is an effective way to document your code. For example, if you want to state that a specific condition should always be true in your code, then using an assertion can be better and more effective than a comment or a docstring. To understand why assertions can be a handy documenting tool, let's say you have a function that takes a server name and a tuple of port numbers. The function will iterate over the port numbers, trying to connect to the target server. For your function to work correctly, the tuple of ports should not be empty. If someone accidentally calls getResponse with an empty tuple, then the for loop will never run, and the function will return none even if the server is available. To alert programmers to this buggy call, you can use a comment as you did in the example on screen. However, using an assert statement can be more effective. The advantage of an assert statement over a comment is that when the condition isn't true, assert immediately raises an assertion error. After that, the code stops running, so it avoids abnormal behaviors and points you directly to the specific problem. Using assertions in situations like this is an effective and powerful way to document your intentions and avoid hard-to-find bugs due to accidental errors or malicious actors. In the next section of the course, you'll increase your knowledge of assertions by looking at their use for debugging. Debugging your code with assertions. At its core, the assert statement is a debugging aid for testing conditions that should remain true during your code's normal execution. For assertions to work as a debugging tool, you should write them so that a failure indicates a bug in the code. In this section, you'll learn how to use the assert statement to assist you while debugging your code at development time. You'll typically use assertions to debug your code during development. The idea is to make sure that specific conditions are and remain true. If an asserted condition becomes false, then you immediately know you have a bug. As an example, check out the circle class that's seen on screen. The class initializer, dunder init, takes radius as an argument and makes sure that the input value is a positive number. This check prevents circles with a negative radius. The area method computes the circle's area. However, before doing that, the method uses an assert statement to guarantee that radius remains a positive number. Why would you add this check? Well, let's suppose you're working on a team and a coworker needs to add the code seen on screen to Circle. This method takes a correction coefficient and applies it to the current value of radius. However, the method doesn't validate the coefficient, introducing a subtle bug. Can you spot it? Let's say that the user provides a negative correction coefficient by accident. The first call to area works correctly because the initial radius is positive. But the second call to area breaks the code with an assertion error. Why? This happens because the call to correct radius turns the radius into a negative number, which uncovers a bug. The function doesn't properly check for valid input. In this example, the assert statement works as a watchdog for situations in which the radius could take invalid values. The assertion error immediately points you to the specific problem. Radius has unexpectedly changed to a negative number. You have to figure out how this unexpected change happened and then fix your code before it goes into production. Developers often use assert statements to check preconditions, just as you did in the previous example. Developers also use assertions to state postconditions. For example, you can check if a function's return value is valid right before returning the value to the caller. In general, the conditions that you check with an assert statement should be true unless you or another developer in your team introduces a bug in the code. In other words, these conditions should never be false. Their purpose is to quickly flag if someone introduces a bug. In this regard, assertions are early alerts in the code which are meant to be useful during development. To properly use assertions as a debugging tool, you shouldn't use try except blocks that catch and handle assertion error exceptions. If an assertion fails, then your program should crash because a condition that was supposed to be true became false. You should not change this intended behavior by catching the exception. A proper use of assertions is to inform developers about unrecoverable errors in a program. Assertions shouldn't signal an expected error, such as a file not found error, where a user can take a corrective action and try again. The goal of an assertion should be to uncover programmers' errors rather than users' errors. Assertions are useful during the development process, not during production. By the time you release your code, it should mostly be free of bugs and shouldn't require the assertions to work correctly. Finally, once your code is ready for production, you don't have to explicitly remove assertions. You can just disable them, and that's what you'll be looking at in the next section of the course.